Hi, good people. We're going to do another reduction of order problem. So here it is, section 2.4 in the textbook. This is video number 2, actually video number 3 on this of examples. So x squared y double prime minus xy prime plus y equals x. And we're given that y1 equals x. y1 is the solution of the corresponding homogeneous equation. Now, every solution that I have here, I'm not going to go through the checking, but I want you to go through the checking and put your checked work into our Google Drive. Anyway, let's work this problem. So here we go. First, we start that y is equal to uy1. That's our first thing, which in this case is ux, because y1 equals x. So y prime is u prime x plus u. Y double prime is u double prime x plus 2u prime. Now I'm going to take these y and the y prime and the y double prime, I'm going to put them into the original equation. So we have x squared times y double prime minus x times y prime plus y, which is, because ux. And now when I multiply everything out, basically a whole bunch of stuff cancels, and I wind up getting x cubed u double prime plus x squared u prime equals x. Now I'm going to let u prime equal v, because I want to get this down to just the first, because this really is, in a way, a first degree, a first order equation, because the difference between u double prime and u prime is really just the difference of 1. So this really kind of is a first order, but to just make it a little more clear, I'm going to let u prime equal v, a little substitution. Then I'm going to divide everything by x cubed, so I can get this in the form of v prime plus v over x equals 1 over x squared. And all I did is I divided everything here by x cubed, and I just substituted v instead of u prime, just because it looks a little bit nicer to me. Now I'm going to solve this. Now I have a very nice, simple first order linear differential equation, and I could do variation parameters. I could do integrating factor. I'm going to do integrating factor. So I is equal to e to the integral of 1 over x, which is e to the ln x, which is just x. So I'm multiplying everything on this equation by x. I get xv prime plus v, plain v, because it cancels that x there, equals 1 over x. Instead of 1 over x squared, now it became 1 over x. Now this is xv. Now xv prime plus v is xv parentheses prime, and that equals 1 over x. So xv is going to equal to the integral of 1 over x, which is ln x plus a constant. I'm going to call the constant k2. I could call the constant anything I want, but I'm going to call it k2, which comes out a little prettier that way, in a way. Anyways, so v is equal to ln x. Now I have to divide out by this x over here. So v is equal to ln x over x plus k2 over x. But v is u prime, so I have to integrate everything. So u is equal to, now the integral of ln x over x, I could do that with a very simple u substitution, and I get 1/2 ln x squared. Not the ln of x squared, but the entire ln x, the whole thing squared. And this is, the integral of this guy is k2 ln x, and there's a new constant of integration, which I'll call k1. Now that I have my u, I want to go and find y. Well, y is equal to u times y1, but y1 was just x, so y is equal to ux, which is this. I wrote it here a little more bigger, so it's a little more clear. Y is equal to, y winds up being 1/2 x times ln x squared plus k1x plus k2 x ln x. Now the reason I made that the first constant k2 and I made the second constant k1 is because this way k1 kind of matches up with y1. So that's all. That's not super important, but to me that was aesthetically nice. Anyway, I took a photo of this. Here's the whole thing. I took a photo of it also, and I put it up on a Google Drive. I want you to check the answer. I want you to take this whole gigantic answer and plug it into the original differential equation and see that the whole thing becomes x, which is really amazing that this long-winded, incredible answer, actually, when you go through all the steps and so forth, it winds up actually answering the differential equation. It actually winds up satisfying the differential equation, which I think is incredible. To me, all of these are like miracles, how these things work, but they do, and I want you to check that out. Okay, that is the end of this problem. Good luck.